Right, one of the main parts of function notation in higher is being able to write a composite function. The idea of a composite function is pretty much as it sounds. But before we get into that, we'll just look at what we did in terms of function notation in National 5. So function notation is obviously just the way that we write things. Okay, that's all notation is. So rather than writing it as y equals 2x plus 7, we'd perhaps write it as f of x equals 2x plus 7. We need to know how to write it. It's not f bracket e, x bracket e equals 2x plus 7. It's f of x equals 2x plus 7. Okay, what that means is basically the function in terms of x is basically 2x's plus a 7. Okay, so if we were to know what x was, we could do 2 times by that x, and then we could add on 7, and we could work out an answer. Okay, so just a revision of kind of what we did before. And this is just going to be quite a visual representation to show you how it works to help you with what we're moving on to. Okay, so just kind of keep this in mind. I've tried doing it for some of the more complicated ones later on, but it's a bit more difficult. Okay, so what we mean when we've got f of x, in terms of this function at least, is 2 times by x plus 7. Right, so if we wanted to find f of 3, all that's happened there is that the x has come out and we put a 3 in its place. And then we just do exactly the same thing in the function on the right-hand side. You take the x out, we put a 3 back in its place. Right, now we've got something we can simplify. Now we've got something we can work out in terms of an actual number. It's just 2 times 3, which is 6. Add on a 7 gives us 13. So f of 3 is just 13. So we take the x out, replace it with a 3, and do the same on the right-hand side. So similarly, if you had f of a, all that's happening here, x comes out, replace it with an a. X comes out, replace it with an a. Okay, you can't simplify this too much, but you can obviously write it slightly differently. It's just 2a plus 7. Okay, and as you can see from above, it's virtually the same. The x has just been replaced by an a. Right, what we're going to look at in more detail in higher, though, is when we have a situation like this, and we're trying to find f of 4x squared. And it works exactly the same way, but what's happening here is we're basically replacing the x with another function. So what we've actually got here is a function of a function. And I know that seems weird. I know you've got lots of words and you just kind of start losing track of what's going on. But all that's happening here is we're taking the x out in the same way as we did before and replacing it with a 4x squared. Okay, so then we do the same on the right hand side. We take the x out and replace it with a 4x squared. We can simplify this ever so slightly and we can find f of 4x squared, and that equals 8x squared plus 7. Right, we might want to use this function for something. We might know something about this function, but we can take it from there once we've established what f of 4x squared is. Right, what we basically move on to in terms of higher, and it's just a slightly different way of writing this, but it ends up in exactly the same way. And I'm pretty much going to use this example to kind of go through in a second. But what you're going to do, as I say, is you're going to find a function of a function, and you're going to end up with something like f of g of x. So you'd have two functions in the first instance, and these are basically the first two functions that I just went through. We have f of x equals 2x plus 7, and we have another function, which we're just going to call g of x, so that we can separate it from the first one. And we're going to call that 4x squared. Right, what we're looking for is f of g of x. Right, that sounds weird in terms of how you say it, and it looks weird in terms of how you write it. But if you look at it closely, all that's happened here is that we've basically got the original function f of x, and you've taken the x out, and you've replaced it with g of x. So it's exactly the same as what we were doing before. Okay, you take the x out, you replace it with g of x. But we know this time what g of x is. G of x is just 4x squared. So the g of x actually comes out and replaced with 4x squared. And you can just write it straight away like this. F of g of x is equal to f of 4x squared. And then we just do the same in the function. We take the x out, we replace it with 4x squared. We take the x out, we replace it 4x squared. And we simplify it down to exactly what we had before, 8x squared plus 7. Okay, it's just we've kind of peeled it back a stage, and what we were looking for in the first instance was f of g of x. Okay, don't be put off by the way it's written. Don't be put off by the way you say it. It is just the same as you've always done. It's just rather than replacing the x with a number, you're replacing it with a function. Okay, and then simplifying it down as much as you possibly can. All right, so a couple of examples here. So let f of x equals x plus 2 and g of x equal to x squared minus 4x plus 1. We're going to find two expressions. We're going to find f of g of x, and you're going to find g of f of x. Okay, so all that's happened here for f of g of x is that x has been replaced with the g of x. So in this function here, we're going to take the x out, and we're going to replace it with this whole function. Okay, so f of g of x, what I want you to do in terms of writing it, first of all, you do get a mark for this, is to write f of x squared minus 4x plus 1. Okay, so the x has come out, we've replaced it with g of x. G of x is just x squared minus 4x plus 1, okay, from the question. So then in the function, f of x, we're going to take the x out and we're going to replace it with the separate function, x squared minus 4x plus 1. So x comes out, x squared minus 4x plus 1 goes in, and then we still need to add 2. Okay, and then we just simplify it in any way we can. All we can do here is just add the 1 and the 2, and we have a new function, f of g of x, which is equal to x squared minus 4x plus 3. So similar kind of idea for g of f of x. All that's happening this time is that the f of x function is going into the g of x function. So we're going to take the x's out, and we're going to replace them with the function x plus 2. Okay, so we start by writing it. G of f of x is equal to g of x plus 2. X's come out, x plus 2's go in their place. So it becomes x plus 2 all squared rather than x squared minus 4 times by x plus 2 rather than 4 times by x. And then we've still got the plus 1 on the end. And then again, you just simplify this as much as you possibly can. X plus 2 squared. Don't be fooled and think this is x squared plus 2 squared. This is FOIL. It's x plus 2 times by x plus 2, which would give us x squared plus 2x plus another 2x plus 4, which simplifies to just 4x in the middle there. Careful with the negative here. It's minus 4 times by x, which is minus 4x, minus 4 times by 2, which is minus 8, and then plus the 1 in the end. And just simplify it again in any way you possibly can. You just got the 1x squared there. If you've got 4x minus 4x, it leaves you with no x's. Plus 4 minus 8, and then plus 1 leaves you with minus 3. So we have this new function, g of f of x. Right, the other thing to look out for is that you might be told, and this is nothing more than just describing it and in a simpler way, it might say that h of x, so this brand new function, is equal to g of f of x. Okay, and I know instantly you're thinking, what the hell is he on about? That's just confusing. Okay, but again, it is a new function. Okay, and the simplest way of writing a new function is just a letter in terms of x. So you might be told that find an expression for the function h of x, where h of x equals g of f of x. Okay, but at the end of the day, all that's happening is we're substituting a letter x in this case for a whole new function. All you're doing in Astro 5 is taking that letter out and putting in a number. All you do now is taking that letter out and just putting in something slightly more complicated. Okay. Right, this second example, I don't know why I've called these 2 and 3 because it should be 1 and 2, but this second example here, okay, is similar, but you might see something like this. You might find f of x. And all that's happening is we're taking the original function and we're basically just replacing the x's with that same function again. Okay, so what we've got here for f of x is f of x over x minus 1. Okay, notice here you've got a domain, x cannot equal 1. Okay, if x was to equal 1, it'd be 1 minus 1, which is 0. We'd have to divide by 0. Okay, but that's not necessarily important for this one. It's important for the question to know that that can be possible. We're not going to do anything with it though. What we are going to do though is take x over x minus 1 and substitute it into this function again in place of all the x's. And just be careful with your notation here. Okay, so the x's are coming out, we're replacing them with x over x minus 1. Okay, right. Basically, the purpose of this one is to try and simplify it as much as you can. You've got lots going on here. You've got functions or fractions and fractions and fractions. Okay, but just deal with each bit separately at a time. Okay, the first thing I want to do is try to simplify this bottom. And what we're basically doing is we've got a fraction, take away 1. If we're going to take away something from fraction, it's basically our knowledge of taking away fractions. And if we're taking away fractions, we have to have the same denominator. Okay, I'm going to do this one slightly differently. Okay, well that's one approach, is to actually do the bottom, and you could do x over x minus 1, basically minus x minus 1 over x minus 1. All I'm doing there is changing the denominator so they're the same, and simplifying it that way. But you could do every term multiplied by x minus 1 here, but you've just got to make sure it's every term. So you've got this top bit multiplied by x minus 1, which gives you x. This bit multiplied by x minus 1 would give you x, and then this bit multiplied by x minus 1 would give you x minus 1. Okay, and then it's a case of simplifying from there, x over x minus 1. Just be careful, you're taking away all of this. So you're taking away the x, and then you're taking away minus 1, in which case you're adding 1, in which case it becomes x over 1, which is just x. Right, as you'll learn later on, this means something. Okay, so when you've done inverse functions, which is the next part of this topic, then you can come back and look at this, and this will tell you something about these two functions. Okay, and it's quite a common question that comes up. But that is basically composite functions. yeah, it's a common question, but at the same time, it's just stuff like this. It's basically substitution at the end of the day. It's just that little bit more complicated. But hopefully, go back through the one when in the previous slide when I'm visually representing it in terms of a substitution, and that should hopefully get you through.